Hi everybody, this is section 1.8. We're going to look at complex numbers in this section. And this is again for Math 101, College Algebra, and this is from our Hawkes Learning System College Algebra textbook. All right, so earlier we talked about real numbers, and I said because mathematicians are so awesome, infinity wasn't enough for us. And we couldn't just use real numbers. We had to come up with our own imaginary or complex numbers. And really what the imaginary unit I is for is to deal with sometimes when we're solving problems and we have a radical with an even index, we end up with a negative underneath. And we still need to continue with our calculations to help out this problem or to finish the problem. So we came up with the imaginary unit I, and really I is equal to the square root of -1. And if we use the imaginary unit I, that can help us pull out that negative out of our radical and help us continue on with our problems. So really, I is equal to the square root of -1. And if you square I, if you square the square root of -1, remember, you end up with, when you square the same thing that's under a radical, you end up with that number. So we end up with -1. So right now, we know that I is equal to the square root of -1, or we can just call it I. It's equal to I. I squared is equal to -1. And we'll continue looking at that a little bit further with more powers of I. So what we're going to do, what we do with I is we use it to pull out the negative under a square root or a radical, a square root. So what we're going to do is if I had something like the square root of -49. Now, if we put it into a calculator, it's going to say a non-real answer. It's not going to work. But what I can do is I can rewrite this as I can do it as the square root of -1 times the square root of 49. We know the square root of -1 is equal to I, and the square root of 49 is 7. So then our final answer here when we simplify is 7I. And we write it typically like we write a term with the number first and then the variable second. You can also like simplify with I. So if I had the square root of -20. It's not a perfect square, but we can simplify it and leave it in radical form. So again, I can break it down into the square root of 4 times the square root of 5 times the square root of -1. I know the square root of 4 is 2. The square root of -1 is I, and then the square root of 5 we can't do anything with. So this is how we use I in simplifying radicals. All right, so here we are going to simplify some radicals with complex numbers. Go ahead and, if you want, try them on your own first. Pause the video and try, and then come back and check. Or if you want, just listen along. So for A, we have the square root of -16. That's going to be similar to the one we just did with the square root of -49. The square root of -16, the square root of 16 is 4. And then we also have to pull out that -1. So we're going to end up with the square root of 16 is 4, and then the square root of -1 will be I. So my answer there will be 4I. The square root of -8, it's not a perfect square, but again, we can break it down. I can do the square root of -1 times the square root of 4 times the square root of 2. And then the square root of -1 is I, the square root of 4 is 2, and then we leave the square root of 2. And the only other thing we're going to do is just rearrange it when we write it. So our final answer will be 2I square root 2. Now, I to the third power. When we work with this, I know we just talked about I is equal to I, if we're talking about it in power form. I squared is equal to -1. Now, I to the third power is going to be, think of it like this. We have I squared times I. We know I squared is equivalent to -1. And we know I is equivalent to I, or the square root of -1, but we're not keeping it in radical form. We're keeping it in complex form. So here, -1 times I to the third power is going to be equal to -I. And really, when we're solving with powers of I, the only one you have to worry about, the only thing you have to worry about is knowing the first 4 powers. If you know I to the first power, I to the second power, I to the third power, and then also let's take a second and look at I to the fourth power. Here, I to the fourth power is the same as I squared, I'll put my 2 there, and times I squared, which we know I squared is equal to -1 times -1. So I to the fourth power is equal to 1. So right now we know that let's do I to the 0 power just to start with. I to the 0 power, anything to the 0 power is equal to 1. I to the first power is equal to I. I to the second power is equal to -1. I to the third power is equal to -I. And I to the fourth power is equal to 1. And I'm going to post another video to help you look at the powers of I and solving problems with higher powers, like I to the 36th power or I to the 47th. And we might also take a look at them in this video as well. Let's take a look at D next, where we have the opposite of I, or -I squared. So here, remember, if you square something, you write it out twice. So we're going to square the opposite of I. So we're going to do -I times -I. Now remember, when you multiply 2 negatives together, you do end up with a positive. So, and then I times I will give us I squared. And then we could go one step further. We know I squared is also equal to a -1. So if you take the opposite of I and you square it, your final answer will end up being a -1. So the next thing we're going to do is we're going to look at just different operations with complex numbers and working with I. When we deal with complex numbers, our answer will typically have what we call a real number part, which will be always listed first, the A, and an imaginary part, which will be the BI. Now, think of them like terms. Real numbers and imaginary numbers, you cannot combine them together. You have to write them as an expression. And when they ask for an answer and they ask for it written in complex form, that means they want it in A plus BI form. So if there was like no whole number, you would do 0 plus your complex number. Sometimes if you just write the BI or the complex part, you are given a pure imaginary number there. But when we look at things, we will write them as a complex number. So we'll write them in the A plus BI form. All right, so we are going to simplify these complex numbers. Again, we're going to write them in A plus BI form, or complex number form. So for A, it is all addition here. So really, all we're going to do when we do this is we're going to combine. It's almost like combining like terms. But here we're going to combine real numbers and imaginary numbers. So I am going to add 4 and -5, which that will give me -1. And then I'll add the imaginary numbers, so 3i plus 7i, which would give me plus 10i. And that's all we can do for that one. We can't do any more because that is imaginary form. Complex form, we have the real numbers and the imaginary numbers, and you can't add them together. right, for B. Now this one's similar to addition, except it is subtraction here. So what we have to do is, remember, you have to distribute that negative to everything in that second set of parentheses. So really, our problem is going to be -2 plus 3i. And then those two negatives there, negative times a negative will give me a +3. And a negative times a +3i will give me a -3i. So now once we've distributed that negative, we're going to combine like terms. -2 plus 3 will be 1. And then my imaginary parts cancel out. 3i, +3i, -3i cancel each other out. So our answer is just going to be 1. If they ask for it in complex form and the answer they don't like 1, you can always try 1 plus 0i. When that 0 stands for there's no complex part. All right, for C, it's multiplication, so we are going to FOIL. So we have 3 plus 2i times -2 plus 3i. So when we multiply here, 3 times -2 will give me a -6. And then we'll do 3 times 3i. And you would just multiply it like you're multiplying terms. So it's going to become plus 9i. And then we'll do +2i times -2. So we get -4i. And then +2i plus +3i is going to leave us with +6i squared. Now, we can simplify the middle terms there. We can simplify 9i minus 4i, and that will give us 5i. So right now we have -6 plus 5i plus 6i squared. But one thing I want you to recognize and look at here is whenever you have I squared, we know that I squared is always equal to -1. So we're going to convert that. So we really have right now, and I'm going to put it up over here, we have -6 plus 5i plus 6 times -1. And then when we multiply 6 times -1, it becomes -6 plus 5i minus 6. And when we go to combine those, -6 minus 6, recall, equals -12 plus 5i. So our final answer is -12 plus 5i. You always want to make sure whenever you end up with I squared when you're multiplying that you convert it to -1 and simplify. All right, so we have one more to do on this page. We have to take D, and we are squaring the expression 2 minus 3i. Remember, when you're squaring an expression, you can't just square the 2 and the 3i. You have to square the whole expression. So you have to do 2 minus 3i times 2 minus 3i. And we'll FOIL. So 2 times 2 is 4. And then we'll do 2 times -3i, so we get -6i. Then we'll do -3 times 2, which gives us a -6i again. And then our last terms are -3i times -3i, so it becomes positive 9i squared. And what we need to look at here is, again, we have I squared, so we're going to convert that to -1. So now we have 4 minus 6i plus 9 times -1, or 4 minus -6i minus 6i is -12i, minus a 9, because 9 times -1 is -9. And then we combine 4 and -9. 4 minus 9 will give me a -5. Minus 12i. And again, you always want to write it in complex form. So you want, excuse me, the whole number part, then the imaginary part. All right, and now we are going to look at our last problem in this section, and this one we need to simplify the quotient. And when we simplify the quotient, they are going to want us to write it in complex form. Just like with radicals, we do not like having I in our denominator. We want to have it in, we want to get rid of it in the denominator. We don't want it in the denominator of our problem. So when we had an expression with a radical, we multiplied by the conjugate. And you are going to do the same thing here. To get rid of that I in your denominator, you are going to multiply the top and the bottom by the conjugate of the denominator. So remember, keep the terms the same, but instead of minus, change it to addition. And whatever we do to the bottom, we have to do to the top. And this one, we will multiply both the top and the bottom out. We will FOIL them. Let's see here. Let's work on the top. 2 times 3 will give me 6. And then 2 times I, so it'll be plus 2I. Then we have 3I times 3, so plus 9I. And then our last terms, 3I times I, so it will be plus 3I squared. All right, and then let's do the bottom, and then we'll simplify. So 3 times 3 is 9. 3 times I will be plus 3I. Negative I times 3 would be minus 3I. And then negative I times positive I will give us negative I squared. And now what we need to do is go ahead and simplify the top and the bottom. My top part, remember that I squared is the same as negative 1. And then, so that becomes 3 times negative 1. So I'm going to have 6. I'm going to combine 2I and 9I. So that's going to become 11I minus 3. On the bottom, I have negative I squared. So it's going to be minus a negative 1. And I have my 9. Now, the nice thing about using the conjugate is those middle terms, positive 3I, negative 3I, are going to cancel. And then negative times a negative is going to give us a positive 1. So it's going to be plus 1. So now when I simplify, 6 minus 3 is 3. So I have 3 plus 11I over 10. But the final thing you need to do is write it in complex form. So you really want to write it as 2 fractions here, the imaginary part and the real part. So we're going to do the real part first. So 3/10 plus 11I over 10, which is the imaginary part. And you do want to break it up. Now you will see as well, they will move, I didn't do it, but we'll move our I. So it's not in the numerator, but it's over to the side there. All right, and that is it for simplifying a quotient.